Hey guys, welcome to the channel IF 4.0. This is Ajay.
Welcome guys, this is the first video, and from this video onwards we will be doing different modeling aspects into the Flexsim. We will understand different tools, objects and latest technologies coming into the Flexsim in due course. As you see, this is the Flexsim screen. This is the Flexsim version 22.0.2. We will be using this Flexsim version and the latest version coming in future for our modeling purpose. So we will begin. So for beginning with the new model, click on the new model here. Then select the units as per requirements. We can select time units, length units and fluid units. For our current first model, we are going to use the time units for minutes. Keep this as meters. Fluid units as of not required. Model start time will not touch as of. Let it be 8 and 21st of July. So we'll go ahead. So as you see, the Flexsim modeling window has opened. So we have number of options here: reset, to reset a model, run model, stop model. We are having a runtime window here. We can put the timings: start timing, warm up time, stop time. We'll understand all these concepts in detail in upcoming videos. So we have a library. This is the object library. As per requirement and model requirement, we can drag and drop these objects onto the floor and we can start modeling. We have this toolbox where whatever objects or whatever programs we will be doing, that would be shown in this toolbox here. We can add multiple things here from this option bar. So we can put dashboards, we have connection options, color platelets, global list, global tables and lot many things. We will understand all these aspects step by step. So today we are going to work on the source. So we will understand the source in detail from start to end. So the source is the fixed resource. So into the objects, we are having task executors, we are having fixed resources, we are having travel networks, conveyors, AGVs, warehousing and lot many. So this is the categorization of objects. So in the fixed resources, we have source, queue, processors, sink, combiner, separator, multiprocessor or basic fixed resource. So we will begin with the source. So the word source itself intimates that it is going to be the start point. So we are going to generate the parts, generate the flow item from the source, and then it will be passed on into the future line of the model. So when you click on the source, on the right side in the properties tab, you will see all these options coming in. So we will understand these options step by step. So this tab here, initially you can rewrite it. So we can rename the source object as per requirement. So we will rename this as generator. So you can see the name has been changed. So this option here is the object tree. When we click on this question mark, we can go to the user manual and read out all the details of the sources. It will take you on the web. Then we have statistics. So the statistics will give you all the statistical details of the source. So you can get the state of the source, you can get the throughput, input, output, current, content, So maximum content, minimum content, this mostly is useful on the station or buffer or the queue. Then we have the stay type, so it is the time calculated, the amount of time the item stays on the object, so that is the stay time here. So this is the statistics. These pins we will understand in detail in future video. So this is used to create dashboards. So the next is template. We will understand this template in detail in the next videos. The high level information of template would be it is the replica of the objects. So we can create 3 to 4 sources which will have a template as this generator, the source. So if the parameters are changed into this generator, the instance generators or instance sources will also have the change in the values. So next comes the visuals. So the visuals you can change for all the objects which are there in the model. So if you want to change the visuals of the source, you can put this 3ds path here. You can select that, you can browse it, or you can have it selected from this list. So when you select that, the 3D shape of this object will be changed as per your selection. You can also change the color of the sources. You can make it red, green depending on your need. Then these are the spatials. So you can put your X, Y, Z dimensions, rotations, sizes here. So this is the location. The top row will be the location. The next row will be the rotation. And then the third row consists of the size. So if you increase here, the size in X direction will increase, and so on. You have another tab here with more visuals. You can put here texturing, you can put animations, you can put the shape factors, you can also check the flags in. We will understand these concepts soon. Then we have labels here. So the label is available in different types here. So number label, string, pointer, array, flex script label, bundle label. So the mostly used is number and string label. So you can put here output and the count of it will be displayed here. So this label, the name itself indicates that it would be a label which will be on the object. So this label is created on the object. So the output label will be on the generator source. Whatever value we will be putting in this label will be shown here and will be stored in this label. This automatic reset, when we check it, it will reset automatically every time we press reset. If this is unchecked, the value will stay as it was entered previously, and with the every run it will go on incrementing. So mostly it is checked to make it automatically reset every time we reset the model for a new run. We have two more options in the labels. One is replace all selected object label with these labels, and copy highlighted labels. So if we have say 4 to 5 sources and we need to copy this label to all the sources, so we'll see this. See, so we have these 4 sources and we have this label as output, but we do not have label on these 3 sources. So what we can do is we will see how to select all the objects at a time. So we need to press and hold the shift key, and then we need to press and hold the left mouse click and then drag it to the area which needs to be selected. Then we need to click on the source from which we need to copy the label. Then we will click on the label, and then we will click on copy highlighted label to alt selected objects. So now if you need to click shift, then you need to click left, so it is unselected. Now if you click on the source 1, you have that label, source 2 you have it, source 3 you have it. Then we need to change this to automatically reset, and then we have the identical sources generated here. Now comes the very important feature of source, that is generation tab, the source tab. Here we are having two main tabs, that is first is flow item class, that is what type of object we need to create from a source. So it may be box, cylinder, sphere, or it can be a custom object, custom flow item which we will be creating, that can also be called here. Then we have the arrival style. So the time interval at which these flow items will be generated needs to be specified in this tab here. So we are having three arrival styles, that is first is inter arrival time, then we have arrival schedule, then we have arrival sequence. So we will first understand the inter arrival time and its features. So here we have one check, that is arrival at 0. So when we check it, the parts will be arrival at 0. If it is unchecked, it will be arrived on the inter arrival time specified here. So we will understand different options present here step by step. So the first option here is the statistical distribution. This is the parameter. So we can also assign inter-arrival time based on parameter. We will see this concept in detail in upcoming videos. So the statistical distribution, we have this long list for statistical distribution. We can have as per requirements. Currently, for example, we have taken normal. We can put the mean value here. We can put the standard deviation value here. So based on the standard deviation, for a time of 10 seconds plus or minus 2, the flow items would be generated from the source. So this is one of the method for inter-arrival time. We can put statistical distribution. The next comes value by case. So the value by case is the strategy where the time will be decided based on the condition. So we can put the label, or we can put based on the item type, or based on the SKU, we can put the source generation time. We will see this by creating some of the examples into the model. So here I have prepared a model for one case study so that we can understand the arrival style in detail. So we have this generator, we have these two sources here, we have three queues, so these are the buffers. So from the source, the parts will be stored in this queue. For generator it's Q1, for source 1 it's Q2, and so on. So we are having one type of SKU, that is type 1 generated from source 1 and type 2 generated from source 2. These parts needs to be combined. For example, we are having a box coming on from source 1 and cylinder coming from source 2. The part needs to be packed in a tote, and then it needs to be parceled ahead. So this is a packing machine, you can say. It is a combining machine. We'll understand these queue combiners in upcoming videos in detail, but currently we will understand what the source is. So for this source, that is generator, it will create a tote. So the flow item selected is a tote from this drop down list. For source 1, the flow item is box, and for source 2, we are having it as cylinder. Now the generator will create a tote, pass on to the queue, and from this queue it will go to the packaging machine. This source will create a box, will come on this Q2, and then it will go on the Q4. And this source 2 will create a cylinder, it will go to Q3, then it will go to Q4, and from Q4 only one type of part will be picked into the packaging machine and will be towed and then send it forward. So we have created a label in the queue. This Q4 is the intermediate queue between Q2 and Q3. So only one part will be coming on this Q4 at a time. So here we have created a label named SKU. So this is 1 or 2. So if the part type 1 comes, it will turn to 1. If the part type 2 comes, it turns to 2. The generator's arrival style is enter arrival time. The source arrival time is scheduled, and the source 2 arrival style is sequence. So we are going to understand the enter arrival time value by case for generator, but the arrival style will understand for source 1 and source 2. So source 1 arrival schedule. So when you click on the edit table, we can have multiple arrivals here. So you can enter 5 and click here, and you can have multiple labels here. If you click that way, you can put the labels on the items produced. As of now, we'll keep label 0. So this each arrival states that for 5 minutes you will have the 3 quantities created for item named product. If you enter here 10, so after 10 minutes you need to put the quantity for item name product. This way you can put the arrivals, its time, the name of the product and the quantity of the product. As of now, we'll put the arrival as 1. So in a 5 minutes we will have 3 parts coming at a time, which is named as product. So this is arrival schedule. In arrival sequence, this arrival time is based on sequence. So if we increase the arrivals, that means that the parts will be generated in the sequence, but it will generate at a time. So at an instance we will have these quantities produced. So for current example, we'll go with the arrival 1. So that says 2 quantities will be product with the item named product. So we have arrival sequence for source 2, we have arrival schedule for source 1, and we are going to produce a tote on inter arrival time arrival style by value by case. Now for value by case, we have already seen it is the method where we can assign a time based on expression or condition. So what we have assigned here is, whenever a part is going to enter the queue, we have put the enter trigger for the queue, which will update the SKU label. So if the part type 1 comes, it will change to 1. Part type 2 comes, it will be changed to 2. And based on that, the generator will create a tote. So if the part type is 1, the generator will create a tote which will require 5 minutes of cycle time. And if the part type is 2, the generator will generate the tote which will require a cycle time of 10 minutes. And default we have 2. So if we do not have 1 or 2 part type coming, if we have 3 part type coming in, then the tote will be created which requires cycle time of 2 minutes. So we have applied an expression for value by case in inter arrival time. Here you can see it. So for part 1, the time is 5 minutes. For part 2, the time is 10 minutes. So now we will begin a run. We will edit the run speed to 15. We will set it and we will make our first run here. So we are running a model. So click on run. So you can see here on Q4 we are having a product name, product type is 2, and the label of the SKU here on this queue is 2. So we are going to service product type 2. So based on that, now the generator will create a tote for this part after 10 minutes. So you can see here we are having this 6 minutes. Once it reached to 10 minutes, the tote will be generated and will be coming to the combiner, and the part will be packed into the tote and set it ahead. So you can see now the tote is created. When I click on the tote, I have created a label for the tote that is named timestamp. After 10 minutes our tote is created. So we are having another product type waiting for getting packed into the tote, which is product type 2, and you can see the next tote will be generated in 20 runtime because it requires 10 minutes for type 2. So I will make this model somewhat faster, and you can see on the 20th we got a tote for part type 2. Now another tote, I'll stop the model, another tote was created on 25th of time for part type 1. So as planned for part type 1 we have spent 5 minutes cycle time for the tote, and another part type 2 we have spent cycle time for 10 minutes to create a tote from a generator. So you can see this way we can use value by case. Applying the expression, you can put different types of expressions here. Based on the case, you can apply the cycle time for part creation. So this way we have understand the arrival styles, all three, and we have understand the second parameter here, value by case. Now we will look into by global table lookup. So global table lookup is nothing but by checking the value in the global table you can put that time for enter arrival. So we can create a global table by coming to the toolbox, coming here, global table, click on the global table, rename the table as generator, generation. So I will put this as row 1 column 1 as of, and I'll enter the value of 5 minutes here. So every 5 minutes I want a part. So here we will assign it. Click on this drop down, generator, we'll click on this. For a row we'll pick this sampler, we'll go to the global table, click on this, click on this. Or else you can put directly here row 1 column 1, it will fetch it, and we'll select the table as generation table. So when we click on the generators, we have row 1 column 1 value to be fetched from the table generator generation. So when we reset it and the run, then you can see every 5 minutes you will have a part coming out. So the next part will come again in 5 minutes, and another again in 5 minutes. So now it has been fetched from the global table. So this is by global table lookup. So you can fetch a value from a global table lookup. Next comes by percentage. By percentage is based on the percentage value you can assign the time. So the total number of the parts produced from the generator, say you are going to produce 10 parts, and if you apply a percentage of say 60 and 40, say 60% of the parts should come in 5 minute cycle time, and 40% of the parts should come in 10 minutes of cycle time. You can apply this percentage and cycle time ratio here, and based on this the generator, the source, will create the parts. Say for example you are going to produce 10 parts, then the 6 parts will come with a cycle time of 5 and 4 parts will come with a cycle time of 10 minutes. So this way you can assign by percentage method